I am super excited to have this, this talk with all of you. I'm super excited to be here in Vox Days. And I am sure many of you know this collection of books. How many of you know them? These covers, at least. You joke around with your colleagues at work and you send them these things when they have imaginary issues. Actually, the only one that doesn't make me laugh is this one, because I do not believe that most issues are imaginary when it comes to scaling. And I am out of power. Okay. Hello. I think that. Okay, the people here are fixing this. Yeah, this is not an imaginary issue, but what wasn't an imaginary issue either was this morning. How many of you took the metro to get here? So I did too, and yeah, I took the metro somewhere close to where I was staying, and then I went to Piazza Uniti. And yeah, and I am walking down the stairs with my luggage, because then I go to the airport, and when I got to the platform, it was like more people, like 4 times more people than there are here. And obviously the metro in Bucharest, then I went and did some research, was first designed, I think, in the 30s or executed in the 40s, and the population of Bucharest was a lot less than it is now, around 850,000, and now close or over 2 million. And that's a scaling issue, obviously, but it's a closed system. You cannot really go around breaking walls down or just digging and laying out new tracks. That's not possible. But when it comes to software, software is flexible, and this is the thing that we need to leverage. But we need to do it from the get-go, because it comes to a point when it's a little bit too late, and then things don't work out as well as they would have been if you would have thought about it from the very beginning. So I'm going to move this away because I didn't make it part of my slides. I just had this idea. And let's suppose that this works. Does it? Does it? It doesn't. Okay. It doesn't. It is. Oh, yeah. I was avoiding it a bit because, yeah, reflection, but here? It's okay? Yeah. So, yes, right now, what I do most of the time is I design architecture solutions for the front end, and I code at 50% of my time. Mostly I do technical lead, so I organize the teams and assign the tasks and so on. But what is the most fun for me is this discovery phase of the projects where you sit down and you see your requirements coming in, and you decide how you're going to make a software project happen, right? And my experience through the years, even when I was a freelancer and I wasn't working at enterprise scale, I had more like small to medium-sized projects, was that there are many things that can go wrong if you don't think about how things will scale in the future. So, have you ever felt like this about a project you're working on, a platform you are maintaining, some legacy code, some new requirement comes in, you don't know where you're going to put it, maybe you put this component here, but yeah, then things get unbalanced, everything falls down. Well, my name is Natalia Venditto, by the way. I work as a front-end architect technical lead in NetCentric. And yes, before we speak about the things that may go wrong, let's speak how things usually turn to be. you are working and suddenly somebody comes and says, okay, you have a project, these are your requirements, there is a set of requirements. You may go ahead and think that you have to put all this project in a platform. Maybe you have existing platform that you can build this in, but let's suppose that you have a new one. And this project is just a tiny fraction of what this platform will become in the future. Usually when you work at enterprise scale, it doesn't happen that the clients have one project for the rest of their lives. They have many business units. Each business unit comes with their own set of things that want to happen, things to promote. They have their agenda. So this inevitably turns into having many projects in a single platform. So even when you start by one project, the mistake I've seen through the years is that people tend to put everything inside of this first, let's say, set of requirements that they have to deliver, instead of trying to move things that may be common, maybe shared, maybe abstracts, into a place where they can be reused in the future when you have Project 2, Project 3, Project N coming in the platform. And it's not an easy exercise. It's not an easy exercise to really decide what belongs in these commons or these commonalities and what doesn't. So we're going to have, well, to think about some tips on how we can do that. Obviously, there is a lot involved in having a scalable platform, especially today. There are some responsibilities that are more in the backend or the server, and we're going to focus right now on front-end architecture. So yes, what are the things that can go wrong? Not this cake, obviously. I would have it very dearly, but yes, like I said, we may fail at deciding what is a common dependency. So when you are in front of your requirement, let's suppose you have a requirement for a component that is a teaser. Everybody knows a teaser. A teaser has an image, a teaser has a title, a teaser has text, and has a button. If you are going to make all these elements into your template for a teaser, you are wasting the opportunity to make each of those reusable. So always try to think very atomically, always try to break down things into problems, and for sure, behind each one of those things, like the images and the button and the text, there is a service, and then you can start already shifting responsibilities from the components to a common area, right? What we may also fail at is sticking to methodologies that help us stay modular. Like, for example, if you're in the front end and you decide that you are going to have modular CSS, which is, I hope everyone does, and you decide you're going to go with BEM, for example, for your architecture at that level, please try to make connections. Like, you have your CSS, and I am going to speak of Angular more in the future of this talk, but Angular already solves that. When we create a component, we have already the template, we have the TS code in another file, we have the CSS, and we know we have to put things together. So always make this connection, component, block. I have a HTML element. Well, that's our element in this methodology. Modifier is for styles. I've seen many people like have a title, no, let's suppose teaser, __, title, dash, dash, I don't know, today. No, today is not a modifier, right? Red, white, I don't know, narrow, that's a modifier because then you can represent it in different ways with styles. Then state is state. State is collapse, is expand, is active. Try to make use of methodologies, and patterns correctly. This is the thing that will save you from scaling issues. Applying patterns in the right way. We also may not, I think I missed one. Yeah, this one. This one is very important because this one is my favorite way of spiraling down into chaos. Finding effective naming conventions. And I am not even talking about naming variables. I know there is a lot of talk about naming variables around and making fun of that, but I'm not talking about that. I'm talking about, if you think of patterns and you think of a system, when you name your components, for example, when you name your colors and your scheme for your website, for example, try to follow a certain pattern of sequence. If you are going to call, for example, you get a requirement and you have a green, right? And most people would call this color green. And then you get another that is a little bit lighter, and then you call it color green light. And then there is another one, and it's even lighter, and then color green light, light, and then color green light, lighter, lighter. Then everything gets messed up. And I'm sure everyone has been there where you say, how am I going to call this? Well, try with codes. It's much easier if you map later a set of codes like C01 to C010. It's our grayscale. And then we assign colors to these codes, and then we maintain a map of what they mean to us, humans. But then we know we can always add another one without having issues. Yes, so tooling. If you don't have a clear vision of how you will grow things, and you don't have, you don't leave wiring, and you don't know how you're going to be doing things, and you rely on manual development or creation of everything, then you're missing out. And there are a lot of tools that help us automate. Simona said it earlier. You try to automate tasks that are repetitive, because if you do it by hand, you will fail, and you will probably deviate from your first idea, and then you will call things something different or create it in a different way, and things will get very, very messed up. And then you don't have a pattern to follow. And you start repeating yourself a lot. Like, yeah, I had this component, but yeah, it had a button, and I created it here, and then I created another component that has a button, but the requirement changed, and the styles changed, and now I have to change it in 2 places, right? And finally, I think this is the hardest part, the communication part. When I was in Angular Netherlands, for me, it was quite surprising that people didn't ask really technical questions about after the talks. They ask, how do I get my team on board of this idea? How do I communicate that I want to use this pattern, I want to use this feature? The communication part is super important. At an enterprise scale, you probably have teams of, 40 developers distributed across maybe Europe or in other time zones. You need to be able to clearly transmit and share your definitions across your team. Doesn't matter if it's 2 or it's 20 or 40. And for that, you need to document it. But documenting definitions of architecture is expensive. It's time-consuming. And you also leave it open to interpretation. If you just pass a wiki page to somebody, this person is, let's say, in another time zone, and they have to interpret it and execute it, they may do it wrong. So how do we come across solving those issues? Well, first of all, from the very beginning, you take a few steps back to those requirements you have for a project that is part of a larger picture or not. You don't know. Maybe you don't have anything else coming in. But like I said before, probably at enterprise scale, you do. So you take a few steps back, and you start trying to decide, how you can break things down into the smaller atomic units, and this is how you start creating these components. And then if you have elements that are going to be probably appearing in many of these entities across your platform, those are commonalities. If there are services that you will probably be using or making consumption of from many components, that's a commonality, right? So this is where I get to Angular. And don't get me wrong, I'm not into these framework wars, because I also develop in Vue, and the only reason I don't do in React is not out of any hatred towards the framework, is because I needed to kind of control my JS fatigue. So one day I said, I'm going to focus on Angular and Vue, perhaps because, yeah, for some reasons, I had some decisions made, but not React, yeah? But why, for me, is Angular the best framework? And this I totally can say it loud when it comes to enterprise scale. Precisely because of all we spoke before. Just imagine that your framework comes equipped with tooling that lays out your project, that lays out your components, and then you have it documented in code. Like, for example, if you write your own schematics in order to create a structure for your project. Well, this is Angular. And schematics actually can be used in Vue, for example. I don't know, like I said, I'm not very savvy about React, but the amount and the detail of documentation of Angular, not only by the community, but also from the core developers, is outstanding. And yeah, it has an opinion. Obviously, it has a very, very strong opinion on how you should do things. But sometimes that opinion is very necessary in order to preserve patterns, preserve conventions, establish best practices, and get things running smoothly. So yes, we are going to be working, or we are going to be suggesting how we could have a structure decided and then put together and documented at the same time in code by using schematics and Angular. And you would need all these packages installed globally, obviously the CLI and schematics and the dev kit. And once you have them, we're going to create our enterprise application. See, because I'm a bit blinded, so since I have to work from here, I hope I do it right. But let's suppose, let me see. I don't know where I am, really. I don't know if I don't see. Let me, maybe I will mirror my computer at this stage. Do you think it's okay if I mirror it right now? No? Command, wow. Yeah, but we had a little bit of an issue with it was shaking, so I don't want to. Okay, so I don't know. Okay. I cannot see, so help me. Is the tilde there? It's not? Ah, okay. Okay, projects. Okay, new. So NGNew, sorry. NGNew enterprise platform. But what we are going to do is we're going to pass an additional flag to create this platform, so we have more control over the structure that we want later, and so we can accommodate more applications in the future. So we're going to say create application equals false, and we're going to let schematics do the magic. And as you can see, the cool thing about schematics used with the CLI or the CLI is that you see everything that's going on. It outputs that you're creating the platform and all the things. And, okay, if we go now and take a look, let's see what Windows disappears. So, okay, I can see it now. Okay, let's. Okay, let's see. We got it here. So we got our new workspace, right, as a monorepo workspace. But as you can see, there is no source, right? There is no code. It's just a package that has all the dependencies necessary to have Angular running, but that's it. You don't have anything else. You have your angular.json, you have your tsconfig, but that's about it. What are we going to create next? Obviously, we do need some code, right? But not having it there already gives us the opportunity to say, okay, what do we want to put in our commonalities? And like we said before, anything that is a component that may be reused, that is stateless, that it's dummy, and that it uses heavily input and output decorators to get information from the context and do its bindings and change things, but cannot be executed as a standalone or put anywhere as a standalone, that's a candidate for a library. And libraries come with Angular since version 6, and the cool thing about them is that they can be packaged, and you can use them anywhere else outside of this context for any purpose you want. Maybe you want to deliver your library to be used in the context of other people's projects because it has some services or whatever that can be used as dependency, or even for yourself in your own workspace to host these particular components that may be reused. So let's go ahead and create our new library. So we're going to use, obviously, schematics, and we're going to do ng-generate library, and we're going to call it client core lib, for example. And we're going to pass a prefix to it. So everything that gets created inside of this library is prefixed, and we are already establishing a pattern. This is the naming convention that adjusts to anything that is core lib to me, that can be reused. Okay, so it's taking a bit. And now we have it. And we can see it here. We can see that we have another folder called projects. That was schematics that did that. We didn't have to do anything additional. And we have our client core library. We have our source, and everything here is correctly prefixed. But again, this is not code that can be served. This is not the purpose of it. This is not an application. This is code that has to be reused by something else. So we need to create, and we're going to create now, our first application that we suppose it's going to be one out of many, right? So let's do that. Let's go back to the terminal and say, okay, schematics generate an application, and we're going to call it client app 1. Again, it's unlikely you call your applications like this sequentially 1, 2, 3, 4, 5. That hardly ever meets needs. But try to think of a way of representing a certain connection, because as you will see now, this application will get also created under folders, under projects, sorry. It's one more project for Angular. Just imagine when you have dozens of applications under this folder, it will start getting a little bit messy, especially if they don't follow any pattern in the naming, right? And why they are there, and you cannot even pass a path, because they are following the abstract abstract syntax of Angular, which says in the schema that they need to follow this pattern. And I can show you that if we go to the node modules and we go to Angular, and we go to the CLI, the library, and the configuration, and we open this schema here. This is the schema that Angular or the CLI is following in order to create every type of object we were creating now, be it an application, a library, or whatever it be. And it says, yeah, it's a type of object. But then if you go to the angular.json, sorry, not this one. Where was I? Okay, let's go back and open the enterprise. Oh, yeah. I was in the same place, sorry. Okay, it's a bit difficult to do it here. Okay, so if we go here and we go to the angular.json, we can see that the abstract syntax tree is represented correctly. We have the project, and then we have the core lib, and then we have the client app, right? And then if we had many, all would be under this folder following this schema. Okay, so now if you've read the style guide of Angular, it tells you it's a good idea if you separate your symbols into some folders, right, that represent each of them, like the enums in a folder, the components in another folder, the service in another folder, and I think we all agree that that will help greatly into keeping things organized and being more scalable. But Angular doesn't provide a system to do this, because why? Because every project in the end is different, and you may have different needs. So what we're going to do is we're going to create our own schematics to generate this structure, right? So I have it ready for the sake of brevity, but anyway, we can go and we can go back to the projects here, and we can create our new schematics. And you will see how easily and straightforward it is to create a schematics. You just, once you have installed what we mentioned before, you have the schematics and schematic CLI installed. So you go and say schematics blank, and you pass a name. And for example, in this case, we're going to say it's called test schematics. And again, you can see schematics working, doing its magic. It's creating the test schematic. And if we open it, oh, sorry. Okay, so we see it's a package as well, and it has a source in this case, and it has a collection here, and it has the test schematic that we passed as name, and an index.ts. And if we open this index.ts, we see that it is a function with the name which is passed, sorry, but it has undergone some transformations, right? It has been camelized, and it's expecting you pass some options, because this is a rule factory, you pass some options, and it takes an input, which is a tree. We're going to speak about this in a minute. And it also returns a tree. And this is basically what schematics do. They expect you to pass options to tell schematics what to do over a tree. It performs these actions, and it generates some code. So back to the presentation, and scrolling a bit, we're going to finally get to schematics. So like I said, schematics are descriptive code generators that transform the workspace. But they're safe. They're safe to play with because they always run in dry run mode. So what is a collection? We just saw the file. We're going to see it more in depth now. A collection is a definition of our schematics. Every time you write a schematic, it has to go into this collection. Otherwise, it won't apply. It has a schema that is a JSON file that validates the input and the description. We will see it in a moment, too. And we also, when we're talking about schematics, it's good that we understand what a rule is. A rule is a function, that takes a tree or a source, if you don't have a tree already, and returns another tree, or even an observer of a tree. You can have dependencies on RxJS and use observers to observe your tree. This tree also integrates a staging area. You can think of it a bit like Git, right? You can think of these actions as being things you commit, and only if you push them, like with this dry run mode set to false, will apply, and will apply real transformations. And then there are the actions that come inbuilt in schematics that are to create or generate new files, for example, rewrite, to rewrite them, overwrite them, or delete them. So basically, again, what is a schematics? Well, or what features schematics? They feature safety because you're safe to run them, and because you can change them, like you can pass a schematics with its input and its options to another schematic and change them over and over, then you also know that if one of them fails, the rest are never executed. So this is the best part, that you're super safe to apply big transformations to your tree, and know that if anything goes wrong, well, you won't be so much going to have to revert back to where you were. So what are we going to do now with schematics? Well, we're going to generate a dedicated folder for every symbol, and we are going to create alias so we can import effectively our symbols in our code. So as you could see, some of the problems we presented earlier, like leveraging tools, preventing code repetition, avoiding inconsistency across repositories in large organizations, for example, or large teams, and creating code, documentation with code directly. All of these things are solved now with schematics. So let's go back to, this is not thank you yet. We're going to, you're going to have to hear me for another few minutes. So basically, like I said, I have already the schematics in my computer, because writing them would take maybe some time, but you have to think that it's something that you write once, and then you can reapply to every one of your applications in one platform, or even across multiple platforms. But to use them, and let me find them, because we have them here. They're called, I think, platform schematics. They're called, yeah, plat schematics. Okay. Structure. We're going to take a look a little bit more in depth to this. So here we have the two schematics already written, right? And if you take a look at the collection, I've already added them to the collection with a description and the factory that they must be applying. So if you take a look, for example, for the platform aliases, you have a plat aliases factory, and that's represented by this file that basically, when it was created, grabbed the name, it camelized it with a set of utilities for strings that schematics brings inbuilt, and it's also here chaining and passing another schematic and its options in order to generate a structure and create the aliases to do imports. So we have the collection with the 2 schematics, and also here we have another file called schema.json, which is very important because this validates the input of your schematics. So you say, okay, my schematics is an object that has some properties. One of them is a name, and the name has to be a string, and it's required. So if you don't pass it, for example, and in this case we have both options as required for name and path, if you don't pass them, this won't work, and it will trigger an error. Okay, so what we're going to do in order to use this, in our platform, I already created a link, and we're going to link it to our plat structure. Is it called plat structure? Yeah. Okay, and then we're going to do this. We're going to do ng-generate. Again, we're using schematics. We know that the schematic is called plat structure, and that the factory is called plat aliases, and that we need to pass a name. And we're going to pass it like this, client app 1. And you would see that it doesn't matter how you pass it, if in camel case or whatever, because we are saying that we're going to dasherize this, this name, and also the path, which is in this case project client app 1 source app. So now it starts taking a look at the options, and what it did is, remember, you are in the schematics outside of your platform, but you're leveraging it anyway by linking it. And what it did, if I am in the right, no, I'm here. What it did is it went to the projects, to the client app 1, and under app, it created all these folders. How did it do that? Where was it taking this from? Well, here in the schematics, I created, under plat structure, I created this folder called files. It's usually convention. You can call it anyhow, but it's a good practice to do it this way. And then I'm saying, okay, grab whatever we passed. Remember, I passed a camelized name, but it doesn't matter. I want you to dasherize it. And then after this, I want you to create, or below this level, I want you to create a folder for each one of the entities in our application. And I also created an index file. And this index file we will use to do our imports via this alias that is now part of our enterprise. So we have the folders, we have the index. In this case, they are empty, but you can imagine you can have imports, and you can even use the template methods to automate this. And here, if you go to the tsconfig, you can also see that you have this new alias called client app 1. So what happens is, when you create your second application, your third, your fourth, you use the same schematics. Let's imagine you already extended this logic to do a lot more things, to do these imports automatically, or whatever other decisions you made for one application, and you can just transfer these schematics and have your team or yourself in the future use it to generate new applications and keep consistency and scale in an effective way. Okay. So now, yes, we can. I don't know if we have time already. No, 2 minutes. 2 minutes. Yeah, we can. Then in these 2 minutes, go to this. I wanted to show you a little bit what happens in this TS. So basically what we're doing here is we're saying, okay, remember this source we just mentioned, where we defined our structure, just grab it and apply in this URL, apply this template logic. This is an interface that comes with a series of utilities, and after you have generated it, move it to whatever we pass as option paths. And then we have all these other methods like branch and merge and chain, which are part of the staging of schematics in order to create exactly like this, as like a Git stage. You branch, you merge, you create your, or you apply your actions, and then you merge again with your source, and you output this new tree with all these transformations. So now, yes, thank you very much. I hope you start thinking about using schematics as a way of automating. You are already using it if you use the CLI, but it's more powerful if you dedicate some time to write your own schematics and then use them to create consistency across your platforms. Thank you very much.